Download this code from codegive.com, link in the description below. One of the most common issues when working with arrays in C is managing memory effectively, especially when dealing with dynamic arrays. C does not have built-in support for dynamic arrays like some higher-level languages do, so developers must handle memory allocation and deallocation manually. This can lead to issues such as memory leaks or buffer overflows if not managed correctly. Tutorial: Managing Dynamic Arrays in C. Introduction to Dynamic Arrays. Dynamic arrays allow you to create an array whose size can be determined during runtime, which is particularly useful when the size of the data is not known at compile time. In C, you can create dynamic arrays using the malloc, calloc, and realloc functions defined in the stdlib.h library. Key functions: 1. Malloc allocates a specified amount of memory and returns a pointer to it. 2. Calloc, similar to malloc, but also initializes the allocated memory to 0. 3. Realloc resizes previously allocated memory. 4. Free deallocates previously allocated memory to avoid memory leaks. Steps to create a dynamic array. 1. Allocating memory: use malloc or calloc to allocate memory for the array. 2. Using the array: access and manipulate the array elements. 3. Reallocating memory: if you need to change the size of the array, use realloc. 4. Freeing memory: always free the memory after usage to prevent memory leaks. Example code: Dynamic Array Management. Here's a complete example demonstrating dynamic array creation, resizing, and cleanup. C. Include stdio.h. Include stdlib.h. Int main. Int asterisk array equals null, / pointer to hold the dynamic array. Int size equals 0, / current size of the array. Int new size, / new size for reallocation. Int I. / step 1, allocate initial memory for the array. Size equals 5, / initial size. Array equals, int asterisk, malloc, size asterisk size of, int, / allocate memory for 5 integers. If array equals null, / check for successful allocation. Printf, str, memory allocation failed \n. Return 1, / exit if allocation failed. / step 2, initialize the array. 4. I equals 0, I size, I++. Array I equals I plus 1, / assign values. / print the initial array. Printf, initial array. 4. I equals 0, I size, I++. Printf, %d, array I. Printf, \n. / step 3, resize the array. New size equals 10, / new size for the array. Int asterisk temp equals, int asterisk, realloc, array, new size asterisk size of, int, / reallocate memory. If temp equals null, / check for successful reallocation. Printf, str, memory reallocation failed \n. Free, array, / free the old array before exiting. Return 1, / exit if reallocation failed. Array equals temp, / update the pointer to the new array. / step 4, initialize new elements in the resized array. 4. I equals size, I new size, I++. Array I equals I plus 1, / assign values to new elements. / print the resized array. Printf, resized array. 4. I equals 0, I new size, I++. Printf, %d, array I. Printf, \n. Step 5, free the allocated memory. Free, array, / always free the memory after use. Array equals null, / set pointer to null to avoid dangling pointer. Return 0, / successful execution. Explanation of the code. 1. Memory allocation. The program starts by allocating memory for 5 integers using malloc. 2. Initialization. It initializes the array with values from 1 to 5. 3. Reallocation. The program then resizes the array to hold 10 integers using realloc. It's essential to check if realloc returns null, which would indicate a failure in resizing. 4. Finalization. After using the dynamic array, the program frees the allocated memory. Important considerations. Always check the return values of malloc, calloc, and realloc to ensure that memory allocation was successful. Use free to release memory that is no longer needed. Not doing so can lead to memory leaks. After freeing a pointer, it's good practice to set it to null to avoid dangling pointers. Conclusion. Managing dynamic arrays in C requires careful attention to memory allocation and deallocation. By following the steps outlined in this tutorial, you can effectively create and manage dynamic arrays while minimizing the risk of memory-related issues.